All right, good afternoon, everyone. Sorry for the unexpected absence today. Gonna do my best trying to show you how to use the calculator through the video, but if, as usual, help each other out if you need anything. Make sure if you borrowed an ID that you leave an ID or something before you take one. All right, so today we're just going to continue our lessons about correlation and scatter diagrams. So just remember that correlation is a measurement of the strength and direction of the linear relationship. So if you remember from Friday, we have 4 descriptors for scatter diagrams: strength, direction, shape, and outliers. Correlation is just the strength and direction of a linear relationship. So we're going to take a look at the first couple of examples just to go over the relationship and correlation. Remember, we kind of talked about this too on Friday. Statistics can be really any way you want to make things look. So that's why you guys got to be careful sometimes, believing statistics that you see on TV because they're going to paint it so that they want the picture they want you to see. Okay, so some of these could be perceived a little bit differently. In example number 1, so A, it says number of cigarettes smoked by a pregnant woman each week and the birth week of her baby. So you want to figure out if it's a positive or negative correlation. So positive this direction, negative is this direction. So as the number of cigarettes smoked by a pregnant woman increases, what does the birth weight of her baby do? That would be decreases. So this would be a negative correlation. On your homework, you're going to have to, as I say, explain. So you'll just make a chart like this. Write the explanatory variable along the x-axis. So number of cigarettes. And then baby weight. And then you would just show that it's a negative correlation. That's all you have to do. So just put the explanatory variable along the x-axis, the response variable along the y-axis, and then just show it's positive or negative. Okay, now remember that there can be outliers, right? But this is for in general terms. So in example B, years of education and annual salary. Well, as your years increase, what typically will your salary do? It'll also increase. So this is a positive correlation. Okay, number of doctors on the staff at a hospital and numbers of administrators on staff. Once again, there's multiple ways you could look at this. One would be that the more doctors you have on staff, the less administrators you're going to have because of costs. Or the other way to look at that as the more doctors you have, the more administrators you need also. So 2 different ways you could look at part C. Okay, either answer would be acceptable depending on which way you put the explanatory variable. Okay. Part D, head circumference and IQ. That's going to be no correlation. Okay. We couldn't really find a relationship between the head circumference and the IQ of a person. Okay, and then in the last example, we've actually already talked about this one a little bit. Number of moviegoers and movie ticket price. Okay, so as the number of moviegoers increases, what does the movie ticket price do? So once again, you could actually look at this in 2 different ways. Most people look at it this way, that as the number of moviegoers increases, that the ticket price will also increase. Okay, so a positive correlation. Okay, so kind of that whole supply and demand concept. Some people will say, no, wait a minute, this is a negative correlation. That would be Rocky in the background, by the way. Because of the fact that as the number of moviegoers go, the companies can decrease the price a little bit and still make a profit. Okay, so like I said, these aren't exact. The ones on the quiz and test will be pretty straightforward. Okay, so the next part of the lesson has to do with the calculator, and this is where it'll be a little bit tricky, but we'll do our best and help each other out. So first thing you guys need to do is turn the diagnostics on by selecting catalog, which, by the way, it tells you where that is. That's at second 0. And then scroll down, and you need to make sure that diagnostics are on. Okay, this isn't going to work if your diagnostics aren't on. So for some reason, if you ever get an error, I would check that first. Okay. Then it says hit enter twice to activate diagnostics. Okay. So what we're going to be doing today is taking a look at 2 var stats types problems. And so we're going to actually be using L1 and L2. So we're going to put the explanatory variable in L1 and then put the response variable in L2. Okay. So before we go on to step 3, let's go ahead and do that. So taking a look at the example, depth at which drilling begins, that's L1. Time to drill in feet, that's L2. Okay. Like I said, 95% of the time, L1 is going to be that first column, but just double check that it makes sense. Okay, so go ahead, take a moment, type all this data into your L1 and L2. Okay, and then once you are done typing in all this information, you're going to go back to stat, okay, and you're going to highlight calc and then select number 4, which is linear regression. So what the linear regression is, and we're going to get more into depth in this later this week, is the line of best fit. So what line represents the data the best possible, okay? So all we're going to do today, though, is look at the correlation coefficient. Remember that the correlation coefficient is R. Okay. So once you type in stat, highlight calc, and select for linear regression, you go ahead and press enter. Some of you might have more of a list. Then just make sure the first list is L1, the second list is L2. Okay. And then we're just going to find whatever R is. So in this example, R is 0.773. So remember on Friday we talked about the closer a correlation coefficient is to 1, the stronger the positive correlation will be. So in this example, it's a relatively strong positive correlation. Okay. And then one other thing to note about this problem is we'll have to use it in a few minutes. N represents the number of data values. So in this example, just count up how many data sets you have, and that would be 12. Okay. All right, to save time, I'm going to go ahead and just give you the correlation coefficient for example number 2. So if you were using your calculator, this would be L1, this would be L2. You go to stat calc again, go to linear regression, and then like I said, today all you're focused on is the correlation coefficient. And in this example, you are going to get negative 0.806. So once again, also from Friday, the closer the correlation coefficient is to -1, the stronger the negative linear relationship is. So this example would be a strong negative, sorry, Rocky is currently trying to chew my stylus. Strong negative linear correlation. Okay. And in this example, N would equal 15. Okay. Once again, N is just the number of data sets. Okay, and we're going to take this information right here and use it on the next page. So we're going to take n and then take the correlation coefficient. Okay. All right, so let's go to the next page. Okay. And it says, how do I know the correlation between two variables is strong enough for me to conclude there's a linear relationships between the variables? So this chart right here, okay, this is going to be given to you on the quiz. I always get asked that question like 5 million times. It will be given to you. You do not need to memorize it. You just have to know how to use it. So once again, n equals the number of observations or number of data sets. Okay. And what we're going to do is we're going to take that correlation coefficient, and you always use the absolute value of it when using the chart. Okay. Now you just use the absolute value when you're using the chart. So if the correlation is negative, the correlation stays negative, but you would just use the absolute value of it to evaluate it on the chart. So in the first example, we had that n equaled 12 and that r equaled 0.773. Okay. So what you do is you go to where n equals 12 on the chart, which is right here, okay, and you look at that correlation coefficient. It's 0.576. And then look at your correlation coefficient. So 0.773 is greater than 0.576. If your correlation coefficient is greater than the chart's correlation coefficient, then you have a linear relationship, or linear, I should say, correlation. Okay, so once again, you take the number of elements that you have, number of observations, find that on the chart. So in this example, it's 12. Write down that correlation coefficient, which is 0.576, and then look at your correlation coefficient that you found. If this number is greater than the chart, then you have a linear correlation. Okay? If this number, the absolute value of it, is not greater than the chart, then you do not have a linear correlation. Okay, next example was n equals 15. And r equal negative 0.806. Okay. Once again, remember that we take the absolute value when evaluating the chart. Okay. Now, if you go on the chart, we actually don't have an n equals 15, but notice that the correlation coefficients keep decreasing the more critical values that we have. So we can use n equals 14 because if this number is larger than that, then it's going to be larger than the one below it. So taking the absolute value, so 0.806, and then writing down the correlation, which is 0.532, is that greater than or less than? It's greater than, so then we have a linear relationship or a linear correlation. And then the other part on this is then you're going to have to say if it's a positive or negative relationship. So the first example, r was positive, so this is a positive linear relationship. In the second example, r was negative, so this is a negative linear relationship. So sometimes students forget that r was negative in this problem and they say it's positive because they just look at this. Remember that you just take the absolute value to use the chart. Whatever r is, if that's positive or negative, that's the type of linear relationship there will be if there is one. Okay, once again, you will be given this chart. Tonight on your homework, I can't remember if the chart's on it or not, so if it's not on there, then just get out your notes. All right, and then we're actually going to skip all of this and go to the last page. Okay, so this is really what we're looking at right here. It says, can you make a generalization about influential points? So basically, influential points are just points that can affect that linear regression line. So if it impacts the linear regression line, then that means the correlation could change. So this either strengthens or weakens the correlation. Okay, and you can kind of think of this too as outliers, but influential points don't necessarily have to be outliers. They just impact that correlation a little bit more than the other points do. All right, you guys actually have the rest of the time to do homework. Since I'm not there today, please let's do our homework first before we start listening to music, so that way then we can all help each other out. And then when you are done, you can go ahead and listen to music. All right, hope you have a wonderful day. I'll see you guys tomorrow. Thank you. Bye.